let's look at the subsequent one, the last one, which is write down F inverse GX. Okay, and its domain, find its range. Okay, so we're gonna just find for F inverse G inverse X. This would just be G inverse would be here. We found G inverse, right? Okay, G inverse in similar form. So this is G inverse. This is G inverse. Sorry, I wrote this as F. Okay, so G inverse in similar form. I'm gonna write this as F inverse 1. Okay, and F inverse will be this function here, which is sine inverse. So this is actually just sine inverse ln 1 over x minus 1. Alright, states its domain. Domain of G inverse is domain of F inverse. G inverse is the domain of first function, which is domain of G inverse. In this case here, the domain of G inverse is 1 over e to 1. Okay, so it's here. Right. Then the range, however, is a bit tricky. What we need to find is essentially find the range of G inverse to put in the domain of the F inverse. F inverse. Oh, this is a bit it's a bit tricky. Let me think how to explain this part here. So this part here, oh sorry, let me just write this as 1 over e to 1. So the range of F inverse, we need to take to find the range of F inverse, we need to take the range of G inverse, which is actually the domain of G, and we need to put into the domain of F inverse, which is in turn the range of F. Okay, but okay, let's not confuse ourselves. So range of G inverse is actually domain of G, which is actually what we found just now. Domain of G was given, right? Minus 1 to 0. So this is actually negative 1 to 0 here. Negative 1 to 0. So I'm going to fit this into the domain of F inverse, which is actually the domain of F inverse. Okay, the F inverse graph looks like that, right? We know that F. So I don't want to introduce too many inverse function here and so on. So I'm just going to use this graph here. So it looks something like that. Zoom in a bit. So it looks like that. Okay, so this graph here, let me just draw it out. So y equals to sine inverse x. This looks like that. This is minus 1, this is 1, this is pi, and this is negative pi. Okay, so I'm going to take negative 1 to 0 and map into this domain here, inclusive. Minus 1 to 0 is inclusive, sorry. This is inclusive. Okay, so put this as minus 1 to 0 here. So what I get is here. Okay, what I get is here. So this case here, this is essentially the range here is from 0 to minus pi. So this is the range of G inverse F inverse. So this will be, the domain will become minus 1 to 0. And after which this will map out the range of F inverse as minus pi to 0. So hence the range of F inverse G inverse is minus pi to 0. Okay, mapping function there. Oh, sorry, this is minus pi over 2. Okay, pi over 2. So this is pi over 2. My graph is wrong. Okay, so this is an inversive graph. It's pi over 2 because when we reflect, this is minus pi over 2 here. Okay, so it will just it's just the inverse graph. Yeah, so if you draw it up properly, then you'll be safer, but I did not, so this should be pi over 2. Yeah, okay, great. So once done, hence or otherwise find the value of x such as gfe equals to 1 over e. So gfx equals to 1 over e. This will just be, you g inverse both sides. Just remember, when g inverse both sides, you will nullify this g, so this is fx equals to g inverse as such. That will be f inverse both sides. Okay, this will just be e, so this is x equals to f inverse g inverse e. So I'm just going to use a function there, ln e, so this is sine inverse ln 1 over e minus 1 or plus 1 minus 1. So, sine inverse ln here. Okay, so then I'm gonna just put this as this is minus 1 minus negative 1 or 1 over 1 over e. Okay, 1 over 1 over e. So this will just be ln e, which is 1 minus 1, which is actually just 0. Okay, so hence x equals to 0. That's how you do the last part, which is a more interesting one. So if any question in the comments, please let us know, and I'll see you in the next question.